All right, hi everybody. Welcome back to the section 4.4 video. And in this video, we're going to take a look at another example of a non-homogeneous differential equation and solving it using the method of undetermined coefficients. So before we get started, let's just remind ourselves of some key components of this differential equation. What makes it non-homogeneous and the homogeneous component. So this y double prime minus 4y prime minus 12y is our homogeneous component. And from this homogeneous component, we get a complementary solution, y sub c. And this sine 2x on the right-hand side is our non-homogeneous component. And from this sine 2x, we were able to get our particular solution, y sub p. Okay? And a general solution to this differential equation altogether is y equals a complementary part plus the particular part. Okay, so let's go ahead and get going on solving this differential equation. And the first thing we always do with these types of equations is solve the complementary first because that's easiest. So let's go ahead and start our solution. So here we'll say solution. And step one is solve the complementary. Step one, solve the complementary solution using the auxiliary equation. And that's from section 4.3. Okay, so let's look at the homogeneous portion of this differential equation. So the homogeneous portion is that y double prime minus 4y prime minus 12y equals 0. And remember how to solve these constant coefficient homogeneous differential equations. They are typically of the standard form. A, B, and C are constants. So with these constants, we set up an auxiliary equation. So we would have A equal to 1, B equal to -4, and C equal to -12. So when we set up our quadratic equation, or -4 m minus 12 equals 0, well, this factors into m minus 6, n plus 2 equals 0. So when we solve, we get m equals 6 and 2. Okay, and these are distinct roots. Okay, so where am I going to get the solution from? Well, remember that a solution to distinct roots would look something like this. Y equals C1 e to the m1x for one of the roots plus C2 e to the m2x. And so my complementary solution would then be y sub c equals C1 e to the 6x plus C2 e to the 2x. Okay, so that's my complementary solution. So that's, like I was saying, that's the easy part. The most work for these problems is going to be your particular solution. Okay, so let's move on to step two now, and let's get going on our particular solution. So here we go. Step two, form a trial particular solution. So what's our particular component or our non-homogeneous component? It's that sine of 2x. So let's write that down right here. F of x equals sine of 2x. So since I have sine of 2x, when I form a trial particular solution, my particular solution, y sub p, would be a sine of 2x plus b cosine of 2x. Okay, so that's my particular solution. Remember, we have trig, we need to account for sine and cosine. Okay, and when we have our particular solution, we also want to figure out what the first derivative and the second derivative would be because we need to plug it back into the differential equation. So let's go ahead and figure out the derivatives. So this would be y prime. So yp prime, that would be careful with the chain rule here, but this would be negative 2a sine of 2x plus 2b, or excuse me, sorry, I have these backwards. This would be, or let me rearrange these. So this would be, I guess I like writing cosine first out of preference. I think that's why I was getting a little mixed up. But a cosine of 2x plus b sine of 2x, that's my trial. So let's go ahead and take the derivatives now. So then this would be negative 2a sine of 2x. Okay, just be careful with your negative, be careful with the chain rule. And this would be plus 2b cosine of 2x. And so my second derivative, again, be careful with the chain rule, be careful with the negatives. This would be negative 4a cosine of 2x minus 4b sine of 2x. Okay, so we have our trial particular solution, we have our derivatives of it. So step 3 is going to be plugging in these equations into my differential equation. Step 3, plug in my particular, its derivative, and its second derivative into the differential equation and solve for, looks like we just have A and B, so just A and B. So let's go ahead and get started on that. So remember, the differential equation is y double prime minus 4y prime minus 12y equals sine of 2x. So, double prime would be going into y double prime, yp prime goes into y prime, and just my regular particular goes into y. So let's start plugging some of these equations in. And so what we get is negative 4a cosine of 2x minus 4b sine of 2x. Close that off. Minus 4. Let's put some brackets around here. I think that looks a lot cleaner because there's a couple parentheses going on because of the sine and cosine 2x. So let's put some brackets. Minus 4 times the first derivative, which would be negative 2a sine of 2x plus 2b cosine of 2x and then minus 12 times A cosine of 2x plus B sine of 2x, and it all equals sine of 2x. Okay, great. That is my setup right there. Okay, so that's my setup. And now what I want to do is solve for A. So now we're just in an algebra game. And what we need to do is distribute in some of these constants. So we need to distribute in this -4 and distribute in this -12. And maybe drop some of these brackets. So let's go ahead and take care of that. So I'm going to drop these brackets, -4a cosine of 2x minus 4b sine of 2x. And so this would be plus 8a sine of 2x minus 8b cosine of 2x minus 12a cosine of 2x minus 12b sine of 2x, and it all equals sine of 2x. Okay, so what I'm going to do now is combine some of these like terms. So -4a cosine of 2x. I see an a cosine of 2x, -12a cosine of 2x. So we're going to combine some of those. So we'll underline them. And then what else do I have in common? I have a -b sine 2x and another -b sine 2x. -12b sine 2x. So we'll combine some of those. I'll underline it twice. And then the 8a sine 2x and -ab cosine 2x, there's no like terms with those, so those will stay the same. So let's combine some of those, and what we get is -16a cosine of 2x minus 16b sine of 2x plus 8a sine of 2x minus 8b cosine of 2x, and it all equals sine of 2x. Okay, so we simplified these six terms into four now, or yeah, four terms. What I want to do now is group together the sines with the sines and the cosines with the cosines. And so if I group them together, what I would get, let's maybe I want to move sine up front to the front. So let's go ahead and rearrange a bit. And what I would get is 8a, or let's do this. I'll say rearrange to get sine 2x and cosine 2x terms together. Okay, so what this would look like is 8a sine of 2x minus 16b sine of 2x uh, minus 16a cosine of 2x minus 8b cosine of 2x. And it all equals same thing, sine of 2x. And the reason I'm rearranging is because now I'm going to factor out the sine 2x and cosine 2x of these terms. So what this would look like is 8a minus 16b times sine of 2x plus negative 16a minus 8b times cosine of 2x. And it all equals sine of 2x. Okay, and here's where we're going to use one of my favorite algebraic principles, and we're utilizes a lot in these types of undetermined coefficient problems, is we're going to equate coefficients. Okay, so we're going to equate coefficients. If you notice, we have some coefficients uh, that pertain to sine 2x, but we don't have one that pertains to cosine of 2x. So on this right-hand side, we're going to add a plus 0 cosine of 2x as a placeholder. But okay, let's go ahead and start equating the coefficients. So here we are in step 1, or equating 1, we have 8a minus 16b sine of 2x equals sine of 2x. Well, we can equate coefficients. So what this really is, think about there being an invisible 1 right here in front of the sign. We could say 8a minus 16b equals 1. And then for our cosine terms, it'd be negative 16a minus 18b times cosine of 2x equals 0 cosine of 2x. So this is like negative 16a minus 8b equals 0. All right, so that's how equating coefficients really helps us out here to figure out what a and b are. So we have two equations and two variables, a and b. We can for sure solve for a and b. And it's just a matter of which one do we want to work with first. Do we want to work with equation A1 first or equation 2 first? I think I want to work with equation 1 first just because we're not dealing with both negatives. So I'm going to solve for A in this equation 1. So I'm going to move the 16b over. So this is like 1 plus 16b, and then I'm going to divide by 8 to both sides. So what I end up with is 1/8 plus 2b. Okay, so I'm going to use this a as solve for, and now plug it into my second equation, and I'm going to solve for b. So what this becomes is negative 16 times 1/8 plus 2b minus 8b equals 0. And when I multiply in that negative 16, this becomes negative 2 minus 32b minus 8b equals 0. And this becomes negative 2 minus 40b equals 0. And if I add 40b to the other side, negative 2 equals 40b. So b would be negative 2 over 40, which ends up being just negative 1 over 20. Okay, so I have b. We can take b and now plug it back into our a equation to figure out what a is going to be. So I would get a equals 1/8 plus 2 times negative 1 over 20. and that ends up being just 1 over 40. Okay, so we have A and B now. So we're on to our final stages of just writing up our complete solution. So here I'll say step 4, plug A and B into our particular solution. So that means our particular solution, which we had previously, we could backtrack a bit. What was it? A cosine of 2x plus B sine of 2x? Was that our original particular solution? Yep, right here. So we found that, A is 1 over 40 and B is negative 1 over 20. So our particular solution is 1 over 40 cosine of 2x minus 1 over 20 sine of 2x. Okay, so that's our particular solution. And we are almost there. Our last step is to write out our general solution. So remember, our general solution is y equals our complementary plus our particular. So our general solution to this homogeneous differential equation, non-homogeneous differential equation that we've been working on would just be C1 e to the 6x plus C2 e to the 2x, excuse me, negative 2x plus 1 over 40 cosine of 2x minus 1 over 20 sine of 2x. And that is the general solution. Okay, so like I was saying, most of the work is your particular solution. Okay, getting the complementary solution is a lot less work than the particular. Okay, so that is the goal with these, to take your time with the particular. Okay, so thank you for watching this long example. I will see you in the next one. Okay, take care.